Welcome back, everybody. In this video, we're going to be diving into the next video, which is going to be more on logging and trying to gain information from the ASA itself. So there was a question posted on the firewall overview video, and it's actually a legit question. So I want to take a minute and I gave a basic answer, but it's to really give a detailed answer, I felt like I'd have to write a novel, and I didn't really want to do that. So the question was stated, and I kind of chuckled when I first read it. It said, "Why router instead of a layer 3 switch? I'm a noob." And I'm like, okay, well, legit question. And to be honest with you, I don't care what level you are. If you have a question, ask. So my response was, the topology nodes will likely change as time goes on. Are you talking about a specific device or just in general? So the response was, due to what I was reading, how fast a layer 3 switch and it can do everything the router does, why routers still exist, and why in your topology you have routers instead of layer 3. One moment, please. I don't want to cough in your face if I don't have to. Is it just easier configuration like interface gig 0/0 instead of assigning IP VLANs? Now, you're going to be able to clearly see who I'm talking about if you go look at the video, but I don't want to call anybody out in the video unless I've talked to them and been like, hey, is it okay if I state your name in the video? I haven't done that, so I'm going to keep your anonymity as I'm talking. So my answer was, he says, oh, I just passed CSENT, so congratulations on passing. That's awesome. Any career tips? Loaded question. There's actually probably 3 or 4 parts. So let me take just a minute and kind of break down each section. So it's due to what I was reading on how fast layer 3 switches and it can do everything the router does, why routers still exist. There's a ton of reasons why routers still exist. So you have to understand the purpose of the switch and the purpose of the router. The switch's job is to be able to aggregate connectivity inside the network. And originally was, for the most part, developed in order to allow multiple users to gain access to the same internet connection. That's really the main driver behind the switch. So you can plug a bunch of people into the same switch in the same VLAN, and then they can all communicate with one another and still have internet access, instead of having to run physical lines down from your router, which is going to be physically impossible because there's not enough ports for it. So switches have been enhanced over time to be able to do a lot of the things that routers can do, but there's still a lot of things that routers can do that switches cannot. Now it's becoming the level at which, so a long time ago, I don't know how long, but there was a period of time when, a switch was down here and a router's capabilities were up here. Now that has since changed a little bit. I'd say it's more like this. So there's a lot of things switches can do and that routers can do, and there's some things that switches can do that routers cannot. Namely, and it's kind of subjective to the track you're in. So like, for instance, a router is not going to be a really good switch. That's for one thing. But then again, if I'm going to be terminating connectivity on a router that's going to be performing the internet edge functionality of your network, then I'm not going to put a switch there. I might have a switch there in place to provide the ability of taking and plugging multiple devices into a circuit in order to extend that. So let me actually draw this out a little bit so that it makes more sense. So there's a couple of reasons why behind and VPNs and firewalling is oh my I didn't plug in my pen pad, so I'll be right back. Make sure I got the right cable here. Let's see, this goes to here. That's just, there we go. All right. Oh, that's because the camera's plugged into that port. Okay. So there we have it. So now we should have our pen pad back. Sorry about that. Ah, there we go. Perfect. So the reason why I'm going to have a switch here deployed like I do right here that's going to be a key factor, right? It's providing the connectivity between two different routers. Now, I could have a situation where I have an internet circuit that's terminated, right? This could be the internet router. This terminates the internet up here. Actually, let me do a little bit better here. We'll say this is R1, and then up here we have the internet, and then down here we draw a cable. And if you ever see a design like this, and then another set of routers here, router 2, and another one here, router 3, this thing right here, that setup is indicating a switch. Now, this is actually going to be a switch physically right here, and all these routers are going to be the same VLAN. This is where a switch is going to come into play. Now, firewalling and stuff like that, switches are not going to be able to keep up with a router in that respect. There are routers now that can easily outdo a switch, but there's also switches that can outdo a router. So it's kind of an interesting question and a different perspective on the situation. So I'm actually glad you brought that up. Now, when it comes down to the operation of what the difference between a router and a switch is, a router routes and a switch switches, right? That's their goal. Now, the router is going to be purpose-built to do things that the switch cannot. Now, you can add functionality and stuff like that to a switch to be able to do it, but these functionalities are in software. A router is going to be able to route in hardware, versus not all of them, but a good majority of them are going to be able to route in hardware, where switches are going to be routing in software. So they're going to be able to form adjacencies and stuff like that. That's all going to be software based. So even though the functionality might be there, you might be able to, on a switch, you might be able to create a VPN, you might be able to do this, you might be able to do that. But I'm focusing right now on the functionality of security. So that's why I have the angle that I do. Now, if we look at it from the perspective of a routing perspective, this guy right here is basically aggregating all of the internet connections, and this over eventually will be an MPLS network. This section right here, these guys right here will be MPLS routers, and this will allow me to demonstrate VPNs over MPLS. So DMVPN, Phase 2, IKV2 VPNs, Get VPNs, so on and so forth. And then we're going to have internet-based VPNs over here. So traffic that's going over the internet versus over MPLS. And so as we go through and we talk about how this works, you're not going to see a lot of switches as internet routers. That's one of the main drivers, and that's why I have it set up the way that I do. So now if I was to give you an example of that, I'm going to go ahead and put my pin pad down and pull my mouse. If we pull up my console connection, I go to switch. Now, if I pull up the switch and I go to global config, and I go to configure crypto, I can do a lot of the same things. Now, let's be clear here. I'm dealing with a router image that's been kind of manipulated and modified to support layer 2 switching functions. Okay? So if I was to type in crypto IKV2 and come in here and IKV2, IT2, sorry, I can't talk, IKV2 profile and say test, you're going to see configuration wise that a lot of the commands on the switch are going to be that of the same as the router. How can I word this? Don't confuse the operation of the node. So you're trying to, I get where you're coming from, and it's not a bad perspective, nor is it an invalid viewpoint on what's going on, considering there's a lot of functionality that is the same. And I'm not trying to go too deep here. I'm trying to keep it pretty level-headed here. At the end of the day, a router is designed to do one thing, and a switch is designed to do another. As time goes on, those nodes are going to become closer to parity on what they can do, and that's really the important part here. So you might be able to do everything on a switch that you can do on a router. but it's not so much being able to do it. It's, is the performance the same? And are the capabilities the same? If I was to jump on, let me go ahead and pull up one of my home switches here. We go pull up switch 1. And switch 1 is a 3750X. So I'll go ahead and pull up Rob and my password. So, oh, that's right. It's not that password. It's the other one. So here I'm on the switch. If I do a show over, I'm on a 3750G, sorry. 3750X is another platform. But I'm on the IP services, so I should be able to come in here and type in crypto, and I can come in here key. You notice how I don't have all the functionality of the router. Now, if I was to go log into another switch, switch 2, this is a 3750X running slightly newer code. So Rob and my password. So I go to global config and type in crypto. I'm going to have more capabilities. I'm going to have the IKEv2 capability set here, right? IKEv2, and I could say I do a lot of the same functionality. But what I don't want you to misunderstand is, in best practices, it's going to be advised that you not use a switch to do the VPN functionality, because that's going to, and the reason why is because a lot of times in these switches there is no crypto engine that the crypto engine is running in software. A lot of your newer routers, the crypto engine is actually built into the processing of in the CPU, so it's built into hardware. So there's certain things that come into play here that are going to take effect, and that if you don't realize what you're doing, yes, the functionality is there. Yes, could you configure a switch to be a VPN termination endpoint? You could. One of the things here, WebVPN, you're not going to be able to run WebVPN on an iOS switch. You will, however, be able to go to here on R1 and go to global config and type in WebVPN. You will be able to configure a router to be a SSL VPN endpoint. Now, it really depends on what you're trying to accomplish with that. But I know it's been a long answer to the beginning of this video, but I wanted to make sure I kind of gave it kind of a detailed answer, because I think people are going to need that. The other part is why in your topology you have routers instead of layer 3 switches. I just explained my reason for that, because routers are purpose built for that. Configuration wise, I can configure as many ports on the switch just as quickly as on a switch as I can on a router. So that's really not there's no configuration per se enhancement. You're just going to have a fewer number of interfaces on a router than you will on a switch. Just pass the CSENT. Any career tips? Really, honestly, when it comes to that, just keep grinding. Do what you've been doing. I mean, obviously, you're putting in the work and putting in the effort. You're getting through the material. You passed the CSENT, which is not an easy thing to do. I remember when I took the CSENT back 8 years ago. I struggled to pass. I failed the first time I took it, but then I learned from that. And I went and I studied and I learned it, and I came back and I passed it the second time. But that's the thing. I learned from my mistakes and I kept on going. So yeah, that was a really good question, and I'm glad you asked. If you have any more questions, definitely bring that into play, and we can dive into that later on. With that said, and I'm glad I was able to, hopefully I answered your question. Let me know if I did or did not. I'm going to go ahead and close out this stuff here and go back over to the ASA, which is where we're going to be focusing on the rest of our video. So, with that being said, if anybody else has any questions or you'd like to bring something up, please let me know, and I'll be more than happy to dive into what's going on. Now, one of the first things we're going to be talking about in this video is some of the logging capabilities. We talked about SNMP in the previous video and stuff like that, and logging is just as important, because then if you're logging, you can gain information, what is commonly referred to as telemetry data, from the firewall, which is going to give you the ability to go, okay, what's going on, what is the ASA seeing, things of that nature. So these are things that you're really going to need to dive into and focus on when you're dealing with how the ASA operates. Now, I am actually running, I can pull it up on my other screen here. I went out and I downloaded and installed Kiwi Syslog server. Now it's a free service. You can download and pay for it. A couple things that I had to do in order to get this to work. This is the free version, not the eval copy. So there's a difference between the two. So if you download the free version and stuff like that, there's some stuff that can go on with it that you would want to make sure you understand. So configuration wise, there's a couple of little things you need to pay attention to. If you don't already have it installed, you need to install the Microsoft.NET 4.0 framework. That needs to be installed before you can go through and take care of that. Now, the other thing that comes into play is when we talk about how it can log. At the time I was playing with it, as you can see, it is working. So I've got logging working. I'll show you the config to save a little bit of time. What do you call it? I needed to have logging enabled on the ASA in order for it to work. So once I enabled logging there, and I'll show you the commands that I typed in, it's actually pretty easy. On the Syslog server, if you're looking to use the free version and not the eval copy, you need to go to File, Setup, and you need to scroll down to the inputs thing right here. And one of the things you have to do is you actually have to go in here and define the IP address of where you're going to be receiving messages from. So I had to put the IP address of the Syslog server in here in order for me to receive messages. And at the time that I did that, I was like, and it still wasn't working. And I'm like, well, what the heck? So as soon as I enabled logging, and then I started seeing the Syslog messages show up, and I knew I was good to go. So now the commands for these, go ahead and do a show run logging, is you first need to tell it what IP address you're going to be pointing your logs to. In this case here, I'm going to be pointing to 10.255.1.59, which is the same IP address of our PRTG server. And then you need to say, to what level are you going to be debugging? And I said logging trap. So a trap is a message that is sent from the network device to some sort of collection station. Okay. Now you have logging. There's logging. What's the other one? It's an SNMP thing. I can't think of it off the top of my head. Not logging trap. It's logging. It's SNMP related. I forget what it is off the top of my head. But the trap is sent from the network device, so the router, switcher, firewall, to the collection station or a collection station. But the other one is a SNMP poll, I want to say. It sounds right, but I don't think that's the word I'm looking for. But anyway, what will end up happening is SNMP will go out and do a request, or I guess poll the device, and then get a response back. There's also informs, which are acknowledged. So there's that. And then I have logging enabled. I have logging console warnings and logging monitor debugging. So what I did by console and warnings is when I debug something, I'm not gonna get flooded on the monitor port. So on the console, I'm not gonna get flooded with debugs. I will get, if I do show logging, I'll come through here and show logging. If I do, actually, if I would have to, all the logging that I need to do is right here. So if I needed to come through here and like say, okay, well, what's going on here? And I'd be able to scroll through and see what's happening in near real time to see what's up and operational. But if I wanted to do logging here, I would have to go and it's kind of weird. Message on a router, it's show log, and it's just going to show you what you need to see. So at any rate, there's that. Now this is good for sending it somewhere else, right? You're sending it off box to another device, and that's what you need to do for. My chair is stuck at the moment. For whatever reason, you have a Syslog server, and you need to send the messages to that, and that's fine. That's very common to do. Now there's the other one here is on monitor. If you go to the ASDM and you click on monitoring and you go down to, let's go ahead and re-authenticate. Then we have logging, enable logging, click on OK. And logging enable, logging ASDM informational, send. And then we're going to click on view. Now this is going to be the real-time viewer. So we're going to go ahead and bring this over just a little bit. This is really cool because if you're troubleshooting a problem, this is going to be a real-time view of what's actually happening between the ASA and something else. So this is for everything. Like you can come in here and be like, okay, I'm troubled, and if it's real traffic on the ASA, like you've got actual hosts sitting behind the firewall, daily operations are happening. The firewall is going to have a lot of logs. Just it's going to keep spinning all day long. So when we get into things like firewall, where we're actually doing access rules and NAT rules and modular policy framework, all of that stuff is going to start showing up in here, and that's going to be a great way for us to try to troubleshoot what's happening. Additionally, when we get into the VPN section, this is going to be a great way to see if there's any type of configuration errors. There's been quite a few times where I've been working on a project, and the last one that I had was it was kind of an interesting situation. So let me kind of just explain to you what happened and then how we fixed it. Oh, I didn't grab my pen tool. So let me go ahead and just minimize this guy. And minimize this, and minimize this, minimize this. So pen tool out, right there. So basically what ended up happening was a customer of the customer I was working for, it was a customer of a customer, they were a managed services provider doing work for healthcare providers. And so they had a firewall sitting out, in one of their data centers. They connected into some LAN behind the scenes. And this guy had an internet connection outbound. And then they had another firewall that came back to another location that we managed over here. And so this guy connected in here, and they were going over internet-based VPN. And then there's a LAN segment sitting behind here and all that other good stuff. So they were trying to communicate between each other. So this side here, which was the consultant side, was trying to access servers for their customer. Server, and this is the client site. Now what was happening was, and I did not originally configure this, was a coworker of mine at the time. He worked with between this side, I think, was a Fortinet. This was a Fortinet, and this side was an ASA 5510 or something like that. But they both speak VPN. And so what was happening was they were trying to form a VPN between these two ASA, or these two firewalls, in order to allow the consultants to reach out and access the server sitting behind the scenes. Well, they had been very specific in their crypto ACL and said, we need to allow the 10.1.1.1/32 and to the 172.16.21.16 or whatever the IPs were. I'm just spitballing IPs at the moment. And that's what they said. So we literally configured on this ASA right here. We configured the ASA and we said, okay, this is what we need to do. So we created a host route ACL to match on that, mapped it to the crypto map, and we had everything going. So what ended up happening was, on their side, they did not do this. They did this. Well, this would work if both sides had flipped. So this is the source, and our destination was 10.1.1.1/32. This was the destination. So that's how we created our ACL. They created their ACL to 10.1.1.0/24, going to, as a source, to 172.16.21.16 as the destination. That doesn't work. It's not gonna. It's gonna be one way, and that's basically what was happening. It was one-way communication between the ASAs, or the firewalls, I should say. And so It probably went out for about a week. I saw the tickets go back and forth, and trying to recall, it's been probably about a year and a half. But tickets went back and forth. I looked at the config that my coworker had put in because he was like, Rob, can you take a look at this? Because I was the proverbial VPN expert. And I mean, just because of the fact that I have a CCIE, I was a proverbial expert in everything, which is not true. And so I said, okay, your config is fine. I'm like, but see, that's the drawback to VPN configuration is it's got to line up on both sides in order for it to work. And we only saw half of the config. So I said, so your config looks good, assuming that their side is set up correctly too. And so the engineer that I was working with, he was of the nature of, please confirm. So please confirm, please confirm, please confirm. Well, you end up getting into a loop where it's, they didn't send anything over, but said it's still not working. But yet you're saying, please confirm your settings are set correctly. They're saying their settings were set correctly, and they're still not working. See the problem here? So finally, I said, individual, have you logged on the ASA to see what it sees? And he goes, no. I go, okay, let's do that. Because now we're a week in. Well, for 4 or 5 days or whatever it was. So I pulled up the real-time log viewer, and lo and behold, we saw the VPN traffic going back and forth. And then in the log viewer, it specifically saw this right here. They were pointing to a host IP address and a /24. So what we ended up doing was we just did the same thing. We took and did, they were actually doing /24s on both sides on theirs. And so we just did the same thing on our ACL. I was like, you know what, let's just rebuild the ACL, make it mimic what they're doing, and then that'll fix the problem. And then he turned around and and his reaction was priceless. I'll never forget it. He turned around and said, that's not how they wrote their paper. And I laughed and I go, of course it's not. But it's not working, and we needed to get it to work. Because you spent way too much time on this. We need to fix it. So here's what we need to do. And I said, and so he was afraid to make a change to something that differed from the documentation. Because he was afraid he was going to get yelled at. And I said, okay, yelled at for fixing it. Okay, I see where you're coming from. There was a little bit of sarcasm, but also a little bit of understanding. So I said, I'll do it. So I jumped on the firewall. I made the ACL change. And as soon as we did that, we could see a bunch of pings going back and forth. It was ping city. But that was one of those things where the real-time log viewer, I was able to look at that and go, oh, they goofed up their ACL. I mimicked what they had instead of, and that's one of those things where if you can fix the problem on your side without having to make them do it on their side, why not just do it? Now, and I understand, security track, you're like, well, wait a minute, that could expose you. You're right, it could. But at that point in time, they had gone, and honestly, and I don't remember the name of the customer, to be honest with you, or else I kind of would like to bash them a little bit, because they have repeatedly said our configuration is correct. And so what I did was I responded to it. I go, okay, here's what the fix was. And I took a screenshot of their documentation. So I literally took my phone, I took a picture of the specific ACL, the way that they wanted their ACL written. I said, this is how the ACL was configured on our firewall and was explicitly defined per your request on your VPN sheet. However, and I also took another screenshot of what I said, this is what we received in the VPN log viewer on our firewall. This is what we received from your side. Your side and what you wanted configured are two different things. I had to modify our firewall to meet your minimum requirements so that the VPN would come up and running. All I got back from that was a thank you for fixing the problem. We see the problem, we can connect into whatever devices now. And so it was actually kind of funny. The guy that ran the organization that I was working with at the time came downstairs and asked me why I was kind of snarky about that. I go, well, you ask the same question over and over and over again, but you get the same response, but something's still not working. So what do you do? And so I went ahead and I modified the config. I said I wanted to highlight, okay, this was not right, this was not right, this was not right. This is why things weren't working. And he goes, oh, because I thought you were trying to be a D-bag and called him out. I go, I was, but in a professional manner. I said, you call me up and say, hey, Rob, I need you to configure this and do this. You pay us to do this, but then you don't even do what you say you're going to do. That's a problem. So rather than make them fix their stuff, I went ahead and fixed our side. The problem was resolved. The customer never called back up. The consultants were able to reach into their ASA or into the servers behind the ASA and get their job done. At the end of the day, it's just do whatever they need you to do. If you can do it yourself and you're not going to be doing anything that's, overly bad per se, then that's what happens. And he's like, oh, okay. He didn't agree with my tone. That's what he was complaining about because he didn't want to burn a bridge. But I go, if you show them that you're willing to fix the problem, I almost guarantee that people are going to be what's the word I'm looking for? Receptive to that, and they'll know that, okay, if something's not right, Rob's going to fix it. And that's what ended up happening. We had a couple problems occur. This particular company, the consultant side, had problems with other customers. And what do? They reached out to us. Because why? We fixed something. We must know what we're doing. So we basically told them, sure, we can look at anything. This is our consulting billable hour. We never heard from them again. But that's just the case in most cases. Because they wanted to get something for free, and we weren't going to work for free. You want our expertise? Sure. This is how much it's going to cost you to get it. But anyway, that's where the real-time log viewer came into play and helped us out. But that's one of those things where if you understand what it is you're doing, then it's pretty much a piece of cake to figure that out. So I've showed you logging. I've showed you how to do it on the ASDM and stuff like that. There's not a whole lot more to it than that for what I really wanted to go through. As far as I am concerned, everything looks to be pretty good. And until next time, guys, take it easy.